What's going on, Chem 20s? Mr. Walton here. Today we're going to be talking a little bit more about stoichiometry. Yesterday you would have learned that when we're doing mole to mole stoichiometry, when we're converting from the moles of one substance to the moles of another substance, we need a couple things. We need a balanced chemical reaction, and then from that balanced chemical reaction we need to get the molar ratio. And the molar ratio is what allows us to convert from one substance to another. Today we're going to take that an extra step further because we rarely measure moles in the laboratory. You can't go out and measure and look at a sample and say, oh, there's 3 moles of that substance there. What you need to do is you need to measure some other things and then calculate the number of moles. And so that's what we're going to do today. We're going to be talking about something called gravimetric stoichiometry. And so what I need you to do is I need you to take out your data booklet. I need you to take out a calculator and then take out whatever you're using to write down your notes. So this is gravimetric stoichiometry. Now, the reason why we're talking about gravimetric stoichiometry is because that's how you weigh things out in the lab. You use a gravimetric balance. You use gravity, the force of gravity, and then the balance figures out what the weight or the mass of a substance is. And so gravimetric just means using the mass in order to figure out how much of something you'll make, or figuring out the mass of a substance you're going to use up or produce. Now again, anytime we're using stoichiometry, we need the molar ratio between the 2 substances that you care about. And remember, it's always unknown coefficient over given coefficient. The coefficients of the unknown substance divided by the coefficient of the given substances. Now, because we've got mass involved, we're going to be dealing with grams. Mass is measured in chemistry in grams. And I don't know if you remember from yesterday as well, from the first half of class, but if you have mass, if you have grams, and you want moles, right? We're using the molar ratio. We're going to need moles, or we're going to get moles at some point in time. Anytime you're dealing with the mass of a substance, you're going to need the molar mass. So you're also going to need the molar mass. And that's one of the reasons why we went through molar mass calculations yesterday and these mole conversions. So we're going to be using molar mass, which is measured in grams per mole. We took a look at our data booklet yesterday. Remember, that's on the very first page after the periodic table, is where we define all of those units and all of the things that we're going to be needing for our mole calculations. Okay. So let's go ahead and let's get started into an example. One of the best ways to learn is just by doing it. So we're going to go ahead and get started with an example. So example number 1. In the following reaction, what mass of zinc oxide will be produced if 21.0 moles of oxygen are reacted. Give you a second to write that down. what mass of zinc oxide will be produced if 21.0 moles of oxygen are reacted? Now, in order to do this, we need a balanced chemical reaction. It doesn't tell us a reaction in here. It just gives us what mass of this thing if we reacted that thing. So we don't actually know what the chemical reaction is yet. It would give you the chemical reaction. But some questions, they ask you to make the chemical reaction and then do the stoichiometry. So what we're going to do is we're going to kind of go baby steps. We're going to make the chemical reaction and then balance it with each other, and then we're going to do the stoichiometry. So in this reaction, we're taking zinc sulfide and we're reacting it with oxygen, and it's making zinc oxide, and then also sulfur dioxide gas. There's no way you would have known if that was the reaction unless we told you that, you know, this is the stuff that was reacting and that's the stuff that was being produced. Now, these are the formulas, right? Zinc is 2+, sulfide is 2-, so just one of each. Oxygen is element, O2. Zinc is 2+, oxygen, oxide is 2-, good. And then sulfur dioxide is molecular, so they have to give us the whole formula. When we're balancing this particular reaction, we'll go through and we'll kind of take a look at you know, what's the most complicated substance. And for me, I don't know, probably the most complicated substance is this last one. So I look at sulfur dioxide. It's got 2 elements and it's got multiple of one of the elements. So that's maybe the most complicated. I am, however, going to notice that oxygen is in 3 different substances. So I'm going to do oxygen last. I'm not even going to look at it until the other ones are balanced. So 1 sulfur, 1 sulfur. Good. 1 zinc, 1 zinc. Good. So now I'm forced to deal with the oxygens. I've got 2 oxygens, and 1 + 2 is 3 oxygens. So that's not helpful. What I need is an even number of oxygens on this side. Hey, come on in. Nope, come on in. Okay, sorry for the interruption. We need an even number of oxygens because we have groups of 2. So I'm going to put a 2 in front of here, in front of the odd number of oxygens. So because we did that, 2 zincs, we need 2 zincs. Because we did that, 2 sulfurs, we need 2 sulfurs. And so now we've got 2 oxygens, 2 times 1 is 2, plus 2 times 2 is 4. 2 plus 4 is 6, we need a 3 here. Okay, no problem. So now that we have a balanced chemical reaction, we can get the molar ratio and we can start putting the pieces of information underneath who they belong to. So what mass measured in grams of zinc oxide will be produced? So I look at zinc oxide and I'm going to go grams ? I'm telling myself, you're telling yourself, that's what we're looking for. And it's really powerful to tell yourself what you're looking for because that focuses you on that substance. Okay, no problem. What other piece of information? 21 moles of oxygen. So I'm going to look under oxygen, and I'm going to go 21.0 moles. Now this is really important. Make sure you write that down, but then bring your attention up at the front to me. If you're being given the moles of a substance, you don't need any extra information about that substance. So yesterday we were able to do a stoichiometry successfully with just the moles of a substance. That's great. So if you have moles of this, you don't need anything else there because the molar ratio will allow you to convert it into moles of something else. But if you want a piece of information, or if you're being given a piece of information like mass about a substance, you need an extra piece of information. You need somehow to get moles as your unit here. So, if I'm being given the mass, or if it's being asked for the mass, I also need the molar mass, because the molar mass allows us to convert between mass and moles. So whenever you're being given mass, you need the molar mass as well. So we'll take a look at zinc oxide. We're going to take a look at our data booklet. We go into our data booklet. Zinc is 65.41. Okay, no problem. Oxygen is 16. So we add those two together, we're going to get 81.41 grams per mole. So underneath zinc oxide, if it's asking for the mass, you need the molar mass. So let's write down the molar mass. 81.41. 81.41 grams per 1 mole. This is the way I write it. You can write it grams per mole. But I find this really helpful because if I write it this way, then unit analysis becomes a lot easier. I know that this is a fraction with grams of zinc oxide on top and then moles of zinc oxide on the bottom. Good. So in here, we're able to get moles somehow, grams and grams, good to go, moles, good to go, moles, good to go there. Now the only other piece of information, the way we convert from one substance to another is using the molar ratio. So the unknown over the given, in this case, is the coefficient of the thing with the question mark, the thing we're looking for. 2 moles of zinc oxide over 3 moles of oxygen. Now I can take all of the information that I need and do some unit analysis on it. So let's just take a second. Let's just kind of reflect on what happened. It gave us the moles of oxygen. We don't need any other piece of information for oxygen. It asks for the grams of this substance, zinc oxide. So if it's asking for grams or giving grams, we need molar mass, grams per mole. And then the way to convert between any two substances is the coefficients. Remember, this 3 means 3 moles of oxygen for every 2 moles of zinc oxide, or 2 moles of zinc oxide for every 3 moles of oxygen. Now we have all of our tools that we need to do unit analysis. So we'll tell ourselves what we're looking for. We're looking for the mass measured in grams of the zinc oxide. That means we have to start with grams of zinc oxide in the top of a fraction here to start with. So we take a look. I'm looking for grams of zinc oxide, so I look under zinc oxide and I try and look for grams. Well, question mark, good, that's what we're looking for. 81.41 grams of zinc oxide per 1 mole. So I'll start with that. I'll start with the molar mass. 81.41 grams of zinc oxide for 1 mole of zinc oxide. Remember, when we're doing stoichiometry, we're dealing with 2 different substances, so we have to label the unit and who that unit belongs to. So I'm looking for grams of zinc oxide, and I have grams of zinc oxide. That's great. Now we just need to cancel out every other unit that is in our equation so far. So in order to cancel out moles of zinc oxide, I'm going to look for moles of zinc oxide somewhere. I look under zinc oxide, and I've already used this moles. I've already used it, so I can't like use it again. So I look for moles of zinc oxide somewhere else, and I see it in my molar ratio. 2 moles of zinc oxide for every 1 mole of, 3 moles of oxygen. So zinc oxide and zinc oxide cancel, and I've used this piece of information, so I'm done with it. Now I have to cancel out moles of oxygen. I look under oxygen and I see moles. Great. I get to cancel out moles of oxygen with 21.0 moles of oxygen. Moles of O2, moles of O2. Okay, not bad. So unit analysis, we were able to cancel out every other unit, and we're going to end up with grams of zinc oxide. I'm very confident about this answer. So you put this into your calculator, and I've got my calculator right here. We're going to multiply all the tops and then divide by all the bottoms. So 81.41 times 2 times 21 divided by 3. Whoa! I get 1,139.74 grams. Now that's obviously not an appropriate number. There's way too many significant digits. If we go back to the original piece of information, it gave us 3 significant digits. So if we go back up here, it gave us 3 digits. So we have to round to 3 significant digits. So here is my first 3 digits. So it's either going to be 113, or because the 3 gets to round up to a 4, 114. But I have to use scientific notation. I have to. I'm forced to use scientific notation. So I'm going to move the decimal 1, 2, 3 times. So 1.14 times 10 to the 3 grams. Now, people who are really good at unit conversions will know that times 10 to the 3 grams is just kilograms. So you could also say 1.14 kilograms. But either one of those is great. Either one of those is a fantastic answer. So it's the same thing that we were doing yesterday. We need a balanced chemical reaction. If it gives us moles, that's not a problem. If it gives us mass or asks for mass, we need the molar mass. And then, as always, you need the molar ratio to convert between the two. Let's try another example. Example number 2. So, how many moles of oxygen are required to turn 160 grams of sulfur into sulfur dioxide? How many moles of oxygen are required to turn 160 grams of sulfur into sulfur dioxide? Let's just think about this for a second. As you're finishing writing down the question, is this a stoichiometry problem? Is it giving you some information about one thing and then asking you about a different thing? Yes, it's giving us information about sulfur, 160 grams of sulfur, how many moles of oxygen. Okay, so it is stoichiometry. That means you need the molar ratio. Well, in order to get the molar ratio, we need a balanced chemical reaction. So let's do step number 1, write a balanced chemical reaction. So how many moles of oxygen are required to turn sulfur into sulfur dioxide? So we're reacting oxygen and sulfur together. So we'll go oxygen plus sulfur. Oxygen's an element, so it's O2. It's part of Hofbrinkel. Sulfur is also an element. Is it part of Hofbrinkel? It's not a part of Hofbrinkel, but it is part of P4S8. So it's S8. And it's going to make sulfur dioxide gas. So SO2 gas. Now, in order to balance this, 8 sulfurs, so we need 8 sulfurs. 8 times 2 is 16, so we need 8 times 2 is 16 oxygens. Okay, so we got a balanced chemical reaction. Good, that's awesome. Now we need to place all of our information under who it belongs to, get the molar ratio, and then we can do our stoichiometry. We can do our unit analysis. So, how many moles of oxygen? So it's asking for moles of oxygen. So I put mole question mark underneath oxygen. Are required to turn 160 grams of sulfur. So 160 grams of sulfur into sulfur dioxide. That's all the question gives you, but we can go a little bit more than that. It's asking for moles of oxygen. I don't have to do anything extra. Moles is fine because we convert using the molar ratio. So this is in moles, 8 moles per 1 mole of sulfur. Good, whatever. So moles is fine, but grams is not. I need some piece of information to convert from grams to moles. And the way we're going to do that is with the molar mass. That's right. So the way you convert from grams to moles is the molar mass. Now, we take a look in our data booklet for what the atomic mass of sulfur is, and it's 32.07. I've got 8 of them, right? S8. So go 32.07 times 8, 256.56. And it's in grams per mole. So 256.56 grams per 1 mole. Good. So that's helpful. Now we have moles. We're good. No extra information. Grams and grams per mole. So grams can cancel and we can get moles. Good. That's awesome. The last thing we need is the molar ratio. The molar ratio is always unknown over given. So it's 8 moles of oxygen for every 1 mole of S8. So that's all we need in order to do our unit analysis. So let's go ahead and do our unit analysis. What are we looking for? I'm not even going to read the question. I know what I'm looking for. We're looking for moles of oxygen. So we're looking for moles of oxygen. Look under oxygen. There's nothing about moles. Ah, shucksy doodles. So we got to find moles of oxygen somewhere else. I see moles as the molar ratio. So I'll start with that. 8 moles of oxygen for every 1 mole of sulfur, S8. This is good. We've got the unit that we want, moles of oxygen. We just need to cancel out every other unit. So I want to cancel out moles of S8. I've already used the molar ratio. I can't use it again. So I'll look under S8 and I'll look for moles. I do find moles, but it's kind of weird. What do I have to do to the molar mass in order to use it in our unit analysis? Yeah, I gotta flip it. So let's do that. 1 mole of S8 for every 256.56 grams of S8. So moles of S8 cancel, and then we're done with the molar mass. We can't use it again. And then probably you've noticed we're going to take 160 grams of S8 and we're going to use that to cancel out grams. 160 grams of S8. Grams of S8 cancel. So now all we have to do is plug this into our calculator. So we're going to go 8 times 160 divided by 256.56. And I get 4.9890 something. Double check my math because I have been known to be wrong. But 4.99 grams, nope. Check out our unit, sorry, moles of oxygen. Perfect. Hopefully this process makes sense. We're going to do one more, okay? So we're going to do one more. Example number 3. And then I'm going to get you to do some practice. A student reacts 50.0 grams of copper with silver nitrate. How many grams, or what mass, right? How many grams of silver will be produced? What I want us to do is I want you to pause the video. You're reacting copper with silver nitrate. I want you to try and predict the chemical reaction. Write a balanced chemical reaction. And it will take like 2 minutes to do this. And then after that, you can unpause the video, then I'll go through it. And then what I want us to do is I want us to think about, okay, what do we need for our unit analysis? So go ahead and pause the video and predict the chemical reaction. Okay, I'm going to do the chemical reaction now. This is weird. Okay, copper. So copper is an element, but it's not part of Hopwrinkle, so it's just Cu. Is reacting with silver nitrate. Silver nitrate is an ionic compound. Silver is +1, nitrate is -1. So we just need one of each. So it's going to react with silver nitrate. And I should have said it was a solution. That's my bad. Aqueous. And this is a single replacement, so the metal kicks out the metal. We're going to get copper nitrate. Nitrates are always soluble, always, right? So I don't even have to look at that data booklet. And then I'm going to get solid silver as a byproduct. Now, let's take a look at this for a second. The copper nitrate, I have to take a look at the data booklet to try and see what is the most common charge, or what is the charge of copper. The most common charge that you're going to make under most conditions is 2+. So I need 2 nitrates for that 2+. So it's going to be copper NO3 in brackets 2. Now I can balance this. So I got 2 nitrates, I need 2 nitrates. 2 silvers, I need 2 silvers. Good. Okay. So we got a balanced chemical reaction. Next step, put all the pieces of information and get our molar ratio. So 50 grams of copper. And how many grams or what mass of silver? So grams, question mark. Now take a look at this. Do I have moles? No, I don't. I don't have moles here. I have grams. So if you have grams, you need the molar mass. You need grams per mole in order to convert it into moles. So we got to look at the molar mass of copper. You take a look at the data booklet. It'll be 63.55 grams per 1 mole of copper. Then we look over on the other side. It's asking us for the grams or the moles of silver. So what we have to do, again, whenever you're given grams or you need grams, you need the molar mass. So we take a look at silver, and silver's molar mass is 107.87. 107.87 grams per 1 mole. Good. So grams and grams cancel. We're going to get moles there. Grams and grams will kind of cancel. We'll get moles there. Now the last piece of information, how do you convert from one substance to another? Is using the molar ratio. So our unknown over given is 2 moles of silver for every 1 mole of copper. Hopefully this makes sense. Grams go with grams per mole, right? Mass goes with molar mass. Mass goes with molar mass, and then the molar ratio. Now what we can do is we can set up our unit analysis. We're looking for the grams of silver. So we're looking for grams of silver. So I look under silver, and I look for something with grams. I do see something with grams. It's the molar mass, 107.87 grams of silver for every 1 mole of silver. Good. I have the unit that I'm looking for. Now I just need to cancel out every other unit. So I'm done with that. I need moles of silver somewhere. So look under silver, don't see moles of silver again because we've already used molar mass. Nothing. Oh, yeah, sorry. 2 moles of silver for the molar ratio. So 2 moles of silver for every 1 mole of copper. So moles of silver and moles of silver cancel. Now I need to cancel out moles of copper, so I look under copper and I find moles of copper. So I gotta flip my molar mass. 1 mole of copper for every 63.55 grams of copper. So moles of copper cancel. And then finally, I've got grams of copper and I need to cancel it. So I'm done with this, I'm done with that. I need to cancel grams of copper. I got 50 grams of copper here. So grams of copper cancel. So now all we have to do is plug this into our calculator. I'm not going to do that, but please plug it into your calculator and see if you end up getting 170 grams of silver. So you put in 50 grams of copper and you're going to get out 170 grams of silver. Hopefully this makes sense. Let us know if you have any questions. You've got a bunch of practice right now that I want you to do. Some of them have balanced reactions, some of them don't, okay? This is an assignment. I think you have lots of time left. Sorry, the bell just went. I think you have lots of time left. So I would like you to get this assignment done for tomorrow. So should be tons of time. Talk to any of the chemistry teachers if you have any help or if you need any help or anything like that. Okay, have fun. Good luck.